these are called erratics. They don't belong here in Winslow, okay? And this is the biggest one.
Oh, that was carried, but it.
Wowie.
So I have a bunch of those in the woods near my house, big huge rocks deposited. I live on Ellis Pond. Is that an erratic?
Yeah. All of them.
They're huge, just like that.
Yeah.
Wow.
Huge or not,
Yeah.
that's what they are. And Mike and Donna brought in a collection of rocks that they got from
Perry, Maine.
Perry, Maine, and it could be any beach in Maine, frankly, where you get a complete assortment of rocks. This is granite, and this came from a granite. This isn't. Anyway, there's a variety of rocks, and you can see why they're called erratics. They don't belong in Perry, Maine. They came here thanks to the ice, and there's always a wide assortment of rocks, and you can make a wild guess of anything that's maybe 100 miles to the northwest of where you're picking up erratics. That's what the geology is. So this is the opposite end. This is the kind of deposit that you find in a glacial lake. These are fine sediments. So I don't know whether any of you have seen pictures of a lake at the edge of a glacier, but the water is essentially like you put flour in water and mixed it all up. And they sometimes call it rock flour because it's that fine. And then it settles, and this is what you find in the bottom of a glacial lake. This funny line coming down here is known as an esker. Esker is a word from Finland, and it basically means that it's a ridge of sand and gravel. And this is a ridge cut in Maine, cut across Esker in Maine. They stand above the landscape, and they wiggle along like that. And how did they ever form? This is how they begin. You may have seen pictures of the ice melting on Greenland. And the ice melts at the surface, and then it forms a kind of a river, and then the river disappears. Where does it go? It goes to the bottom of the ice, funnily enough, and then it actually forms a river at the bottom of the ice. And the river collects all of the sand and gravel that is coming out of that melting ice, and forms one of these deposits here. And as you can imagine, because it's a river deposit, these boulders are mostly pretty well rounded. And I'll show you one of those later. So here are some things that the Geological Survey of Maine has put together, and it's really too complicated for me to explain the whole thing. But this is a till. The T over here is the green deposit, which is usually at the base. Okay, seawater is the pale blue. Outwash plain. What did you see? OP? OP. See how I pronounce it. Well, it's not here yet. Okay. we'll get to that in the middle. In a minute, marine sediments, kettle hull. We'll have to get to all of these things, but I wanted to show you the complexity of the sedimentary deposits and the landforms that they develop on top of ledge. It's always completely separate from ledge. And here's a picture I took of the Bowden approaching Castine Harbour about 20 million years ago. That's what it looked like, something like that. I don't know if any of you saw this picture in the Bangor paper today. I picked it out and put it in here because I thought it was kind of neat. This is actually the Bowden, which is the Maine Maritime Academy's sailing ship. It's about 130 years old, not 130 million years old, but anyway, and it is approaching a scene a lot like what Castine Harbour was like about 13,000 years ago. And then here's another one where the ice has gone, and you're left with all of these landforms, and OP is this outwash plain. This is an esker coming down the middle. You see the E up at the top. This is an esker, and it's covered by other sediments. And I don't expect you to remember all those various forms.
What's drumlins?
Okay, a drumlin. Yeah. A drumlin is an elongated landform formed by the ice, and it's built mostly of till, and it's oriented northwest, southeast for the most part. And then here is a picture, an air photo taken a few years ago of Waldoboro and Warren. And I want you to see that there are roads here. This white line here is actually a railroad line. The red line is the boundary between Waldoboro and Warren. And this line along the top of the map is Route 1. And this is a LiDAR image of exactly the same area. Now, what's LiDAR? LiDAR is light detection and ranging. I want you to remember all of this stuff. It stands for, is a remote sensing method that uses light in the form of a pulsed laser. I don't expect you to remember this.
You forgot to tell us there'd be a test stop.
But this is what LiDAR can tell you about the land surface this LiDAR is like magic to me. It takes away the vegetation that you saw quite clearly here. You can't see the land surface, but here you can. So what are all these funny lines? Can you imagine? The glacier, yeah, retreating. Yes. So, and some people have speculated that each of these shows the retreat over 1 year. So in springtime, they leave a little bit of a deposit. If you were walking over this area, you wouldn't notice very much of a change. And here, I think this is a kind of a drumlin here. You can't see it very clearly, but it's built of till, and it's oriented in the direction of ice movement or ice retreat. Isn't that absolutely fascinating? Yes. I tell you, when LiDAR became available only 15 years ago or so, the Geological Society, the Geological Survey of Maine got really excited because they could, start to map many more things.
So this shows you the same stuff that the mappable lines show you, that the geological survey maps.
Oh, yeah. So the Geological Survey, U.S. Geological Survey maps the topography, which is just the height above sea level.
Oh,
Okay.
So,
This is a bit different. This is the official geology of Maine, and this is a map of. This is the official geology map of Maine, which I have a copy of. Out in Joseph House. These red lines, these funny red lines, are eskers mapped on the surface. You see Augusta and Bangor on this map here. And this blue line was at one time the extent of the Gulf of Maine. Not very long ago. Pardon?
before or after the
No, everything is after the glaciers. Everything, there's bedrock, and then there's after the last glaciation. All the earlier glaciations have basically been taken away.
Is this because of uplift?
You have a good point. That's when you can imagine a mile of ice. It's difficult to imagine what that would feel like, but it pushed the crust of the earth down, and so when the melting was occurring, sea level came up faster than the crust came up, and so sea level came way up here as far as Farmington, and I don't know if you can see Millinocket, almost at the top there, and so sea level came up 70 meters higher than current sea level.
Wow.
And then in a couple of thousand years, it dropped down to below current sea level, and then came up again, and it's been about where it is now for a couple of thousand years.
Why did it drop?
The drop is because the crust came up faster than sea level came up. This is all just relative. It's hard for us to even imagine how Earth's crust would do such weird things.
And we still have some uplift going on, don't we?
Yes, in some, particularly in some parts of Maine. I think the coastal Maine. I think east coastal Maine, really. Yes. As well as, of course, sea level rise caused by climate change. So, so let's get back to where we are. This is the Kennebec River, and the grey up there is the built-up area of Waterville. This is the airport of Waterville. And there's a bit of an esker coming. How many of you have been to the Kennebec Sanitary Water District treatment plant, all the way down the Water Street? Only one? Yeah. Yes. So that's cut out of an. Oops, I've done it again. It's cut out of an esker here, and the esker actually underlies that. I don't like this map because the esker actually underlies the South End neighborhood, even under the PP. Well, you know how the South End neighborhood, as you approach the river, it's really quite a steep drop.
Yes, right.
And anyway, and it goes underneath the Thomas College campus along the coastline. And so here PP is basically a clay deposit. It's where part of the ocean came in for a brief time. So you get some deposits like that. And this is a till. This is basically the till deposit. And then this is a little bit further up. This is actually Fairfield. And there's an esker coming down here. That's the one that actually joins up with the south end neighborhood on the next map. And there's a sandy deposit on the east side of the river. How many of you have noticed the kind of looks like a desert on the thing? Oh yeah, opposite the CMP, where the CMP lines cross the Kennebec River, and they go along Benton Avenue. There's some sand dunes over on that side.
Yeah.
That's only fine sand. That's not esker deposits. There are no. So how did it get there? So one of the explanations that I've heard is that when sea level dropped here, when sea level dropped again like that, there was no vegetation on this surface. So the northwest winds blowing across that esker, that exposed esker, would blow all the sand across the river and ended up in this kind of ridge of sand on the Winslow Benton side of the river. And actually you do see deposits like that quite far up the Kennebec too. Anyway, just fine sand. That's it. That's the geology of Maine.
So it's 140 million years of missing geology.
Yes.
What do you imagine were there life forms on the land, do you think? I mean, did it sustain animals and caribou and lichen and things like that?
Having a wonderful time. Yes,
Must have taken a
I
long time.
do. And in fact, one of the peculiar parts that we don't often think about, and that is that we are now in an interglacial period. One of the things I haven't shown up here is that there were, I think, eight or 10 glacial periods separated by warmer periods. And the warmer periods, yeah, sure, vegetation, animals moved in and out, had a wonderful time.
But that 140 million years was not just a huge period of glaciation.
It wasn't just a sheet of ice a mile high for 140 million.
No.
But there were glacial periods during that 140 million years, or did you just don't know?
No, we only know that there are glacial periods of about the last 1.5 million years. Yeah, it's difficult to keep all the zeros.
It's a real puzzle. It's fascinating.
Yeah.
And it seems so the islands in the middle that are HA, what are those? Those aren't just sand. Those yellow islands.
Yes.
In the river, yeah.
I can't remember, but we'll have a look on the map when we get out into the dunes.
So how does that be a time when the land masses are all one, and then they
Yes.
separated? When you look at pictures, say, of Scotland and Nova Scotia, it looks, just looking at the pictures, it looks like the land masses and the rocks are very, very similar.
Yes. And to some extent they are. They were deposited in the same ocean and just put together like a jigsaw puzzle. So I can see that out of learning a little bit about the geology of Maine, you've also got a sense of the geology of Earth. It's an extraordinary long period of time. And one of the articles a while ago was about sea level and about where the coast is. We all know where the coast is. It's over there. And I know if I can drive down there, it's just like it was last time I was here. So basically, on this map that I had here, shows that it's varied enormously over time. Just one little piece of time.
In the glaciers in the Alps, they're receding, and are you using those models of what's actually happening to get a better understanding of what happened millions of years ago?
To some extent, certainly, it was a bit of a puzzle trying to understand the post-glacial geology of Maine before people had a fellow by the name of Agassiz, who was a professor of geology at Harvard, figured out what was going on with the Alps, that the end of a glacier that leaves certain deposits. And then more has come from this, which includes variation in sea level, as you see.
Is Waterville on one of those eskers above Augusta?
Yes, it's on that one, exactly.
So where does it run through?
It runs through from Fairfield. You know where the Fairfield, the community college.
Yeah.
And have you been up the little road that leads a little bit kind of parallel to the community college road? And there's some solar panels on
Connects you over to 201.
Yes, exactly. Yes. Any of you been on that road? No? Okay, well, that's worth it. Look, that runs over the Esker. Yes.
So like where the Colby ski area is, it's high there, is that the Esker?
That's not the Esker, no. That's rock. Good questions. Yes, like you can't always interpret highland as being rock or Esker. Right.
So, that blue line that shows the extent of the inflow after the end of glaciation,
Yes, let's see that.
where does that correspond to that chart on the right? Is that where the highest
Yeah,
point
that's
there?
the highest one,
That's
yes.
the high point.
Yes,
And at some point, the sea level dropped even below to where it is today.
yes.
Why would it have dropped so low and then bounced back?
Because the the continent was rising faster than
Okay.
sea level. First of all, sea level was rising faster than the continent.
Right.
The continent picked up.
Explain to you.
I'm just curious where the line would be for the low point on that graph of the water point. So if you have the blue line showing the high point, where would the line be for the low point? Because it'd be much farther out in the ocean, correct?
Yes. You'll have to get on scuba gear.
Is that where the Gulf of Maine is? Is it the Gulf of Maine defined by that former?
I don't know the answer to that.
Well, the Gulf of Maine goes all the way up to Nova Scotia, so it's unlikely that it would include all of it.
Right. It probably went
Some
off,
part of
way
it.
off, yes. Almost.
There's different shore frontage back there, that's for sure.
And it didn't last long. That coastal didn't, yeah.
Only 10,000 years or so.
None of them built houses.
It's like an eye.
Yeah.
Geologically.
For a while, you wouldn't have noticed a change.
was amazing, thank you so much.
Yeah.
This is terrific.
Yeah.
You said you were a hydrogeologist?
Yes.
What is the main distinction that you would give between a hydrogeologist? I mean, I know it has something to do with water, but versus a geologist. And if I may ask, what kind of work did you do with that?
Okay, so, let's see where to begin. When I first came to Maine here, I was an assistant up at Colby College. And that didn't last very long. It didn't seem as if it was going anywhere. But then I was appointed as Maine's hazardous waste hydrogeologist. So dealing with the various types of pollution of groundwater that was occurring from various hazardous waste sites in Maine. And I evolved from that into dealing with all groundwater in Maine, and eventually left the DEP to help form a company called Emery and Garrett Groundwater, and we did groundwater studies of various kinds in Maine, New England, even points further south. And in Maine, my particular contribution has been with getting to develop groundwater supplies for various towns up and down Maine. So on the west, I did quite a lot of work in Freiburg. On the east, I developed a groundwater supply for Calais, which was getting its water supply from the town across the border, the Canadian border, and that town said, sorry, we haven't got enough for you, and have to find your own. So I happened to be there to do that. And then particularly Castine, long after the ice had gone. Castine is a town which is on an almost island. And they were islands, it's difficult to find a groundwater supply, because if you drill a vertical well, if you drill too far, you get into salt water. And even if you pump the well, salt water comes up. So I've helped Castine, and now all of the 4 wells that serve the town now are wells that I developed. I'm particularly proud of that.
So digging for wells is hydrogeology.
Yes.
Okay.
It's not just digging, it's figuring
Looking
out.
where it is, right? You have to
Yeah.
figure out where it is.
Yeah, figuring out what
Okay.
the geology is telling you, what's likely to be here, what investigation can we use to say, oh yes, I think we should do this.
And do you use what is that,
Divining.
divining rods?
I leave that to Gina.
Yeah. Because my grandmother could do that. She could walk around with a stick and it would go down if there was water. It was very amazing.
Is there any risk of, because of Poland Spring using the groundwater, of depleting the supply for export of Maine's water?
That's actually a very good point, and it's one that there's a part of Maine state government that deals with that. But I remember that in every new groundwater supply that we've developed for towns, and the same Poland Spring does the same kind of thing, it's how much can this groundwater supply actually continue to supply even in a dry year. And so I think I don't know the details of all of the Poland Spring sites throughout Maine, but I would imagine that principle is used to evaluate each of these sites before the well is permitted to pump a certain amount.
So the government or some branch of it is not letting them pump more than
Right.
they should.
Right.
Tell them about the horizontal wells you invented.
Oh,
Yes,
Yes.
please do.
Yes.
well, it's well, I say. My first adventure in hydrogeology was in the Bahamas. And the Bahamas is a bunch of islands that are very close to sea level, as you know. And so I was hired by the Department of Public Works there, who had put in vertical wells, and they tended to go salt. So what's going on? It was fresh when we started. So what happens in oceanic islands is that the fresh water, which is actually lighter than the salt water, sits as a kind of a pillow on top of the salt water. But but it's all in connection. So there's with the tides, the groundwater goes up and down, just like the tides do, but not as much, because the hydraulic connection, of course, is through the groundwater is a lot less. But if you put a vertical well in and then you pump it, the level of water in the well goes down, right at the well. So that's decreasing the pressure, the hydraulic pressure in the well, which brings the salt up. So the well turns a little bit salty. So as it turns out, in the Bahamas, when you dig a trench, the sides of this trench pretty soon start cementing up, so that it becomes like kind of a loose rock. These are lime sands. When I say lime sands, I mean it's made of what eventually would become a limestone. And so what we did there was we dug trenches in just down below the water table, and so they were only yay deep. So that now you're catching the water from the surface of the groundwater, and because you're catching it over quite a length, you're not decreasing the hydraulic pressure so much. So that worked in the Bahamas because of the ease of actually digging a trench there.
And they're still using those there.
Elsewhere, yes, they still are. Elsewhere, when I went on a rotary trip to a coastal town in Ecuador, I noticed the same thing. They had the vertical wells and they were going salt. So I suggested to them they do a lot of work, especially at low tide, and install a horizontal well. It's difficult in quartz sands because the sides of a trench don't cement up. But if you work hard at it, you can actually do that.
So how do you get
And
the
it
pumps?
works.
How do you have multiple pumps, or, I mean, a right angle pump, or how do you get it from the horizontal
Oh,
back up?
so it's a horizontal well, and basically, have you heard of a French drain?
Yes. Yes.
It's essentially a French drain.
Mm-hmm.
What's a French name?
It's a horizontal well.
Does that count over?
Is that trench getting backed over and?
Yeah, in the Bahamas it was right over.
Oh.
In Ecuador they covered it up. Yeah. And then Jinan is, I think she's trying to point out one of the wells that we have in Castile was a horizontal well that I recommend. And in that case, there was there was a 10-foot sand layer, 10-foot thick sand layer, which is not much more than the height of this room here. And only 5 feet of that had the water in it. So it would be very difficult to get enough water from 5 feet of, you're only allowed 5 feet of drawdown from that. So I suggested, because this sand layer extended out quite a ways, that they put in a horizontal well. So we did a horizontal test well, first of all, which was goodness, 50 feet long or something, and it seemed to work pretty well. And so eventually they put in 400 feet of horizontal well, and it works just fine.
So I have a question. If you have contaminated water at a lower level and then land higher, supposedly the water is not contaminated.
Right?
Is that reasonable? Does that make sense?
That does sometimes happen. And the worst place where it happens is where you get a contaminant that sinks in water. Gasoline doesn't. Diesel oil doesn't. Any of the fuel oils don't. They tend to float at the groundwater surface. But there are some chlorinated solvents that do sink into the bedrock aquifer, and it's a real problem, yes. Yes.
So is there a place in between where there's clean water that you could?
Possibly, but that place where I would recommend is groundwater supply. Right.
What's an aquifer?
What is an aquifer? It's a body of rock or sand that holds water,
Okay.
holds sufficient groundwater that you could pump it out.
I'm from Nebraska, and we're sitting on top, one of the states sitting on top of what I guess is referred to as one of the largest underground aquifers at least in the United States.
Yeah.
The Ogallala Aquifer.
Yes.
But, and I guess it's pretty deep, I
Yes.
don't know much about that, but I've heard the expression primordial water, and whether that's true or not, I don't know, but it implied that water is not replenished by, rainfall or any other outside means that water would be, say, here in Maine. So that it's gonna eventually go dry if they keep, because in the Midwest, they're
Not good for farming.
they're farming and irrigating and everything, and I guess the aquifers are already shrinking, from like in Texas, it's almost all gone from there because of the cotton farms. And it's
It's a
happening.
real problem.
It'll
Yes.
slowly go.
Yes. And that comes back to your question, I think, earlier about how one can regulate solid springs. And that it has become a real problem.
A real problem.
Yeah. The farmers think that they've got it forever.
Yeah.
They haven't.
Forever is gonna end someday.
Well, let's go out and have a look at rocks. We've been talking enough.